All right, video 2 here, talking about absolute value. Now we're going to do inequalities. Okay, so example 3, understand absolute value inequalities. What are the solutions of the absolute value inequality? So again, when you see this absolute value of x less than 3, what you need to think of, right, is that whole distance from 0, except now the distance from 0 must be less than 3. All right, so we're going to have to translate that into our solution set. All right, so again, we're going to think of this as the distance from 0 must be less than 3. Must be less than 3. So on a number line, right, if I draw my number line here, right, we'll put 0 in the middle. So if we go all the way to positive 3, yes, any number in here, right, not including 3, but any number between 0 and 3, that would have an absolute value less than 3. We can go all the way to negative 3, right? Because again, think of distance as positive. Now we can't include negative 3, but anything between negative 3 and 0 would also have a distance less than 3, an absolute value less than 3. So all of these numbers in between negative 3 and positive 3 would be solutions. Well, we learned in section 1.6 how to write a compound inequality. This is an and compound inequality. You have two ways of writing it. You could write it as two separate inequalities with an and in between them, or you can do what I'm going to do and write the one inequality, putting the negative 3 here, x in the middle, positive 3 here. So remember, the first symbol still is going to look like a less than symbol. Now, it's not going to have equal to because it's open circle, but you read it like this, right? X is greater than negative 3, which means x is bigger than negative 3. And then this also is a less than symbol, and you read it like this, right? X is less than 3 and x is less than 3. So this says that x is in between negative 3 and 3. And again, we're not equal to because the symbol here doesn't have an equal to. So no equals. So these don't have any equals. And again, this is the solution set. All of these numbers would satisfy this absolute value inequality. Okay, B now says, what are the solutions of this absolute value inequality? And now we're just doing the absolute value of x is greater than 3. So now we're just taking that inequality symbol and flipping it around. So again, you have to think in terms of distance from 0. But now we want the distance from 0 must be greater than 3. Must be greater than 3. So now if I put a number line here, right? Here's 0. We'll put 3 here. Well, now we need all the numbers that have an absolute value more than 3. So that means their distances have to be greater than 3, which means open circle because it's not equal to, it'd be everything this way. Same thing here. We can put the negative 3 over here. Can't be negative 3, but it has to be everything that absolute value would be greater than 3, which would be all of these negative numbers this way, because again, when you plug them in the absolute value, they would turn positive. And now you have the or situation, right? When your absolute value or when your two inequalities go in opposite direction, this compound inequality is an or because it's either x is less than negative 3 going to the left or x is greater than 3. Your number can fall into one or the other of these solution sets. Let me make that a better greater than symbol. Okay. So be aware of how this inequality works when there's an absolute value. So again, if I leave this here, notice that a greater than leads to an or statement. So that is one thing that you should think of, right? Greater than means you have to be the outsides, right? Going away from each other. When you have the less than, that's going to be the in between. That's when you have the and you put the two numbers surrounding the x or what's inside the absolute value. So let's see if we can do a little bit more complicated one maybe. Here we go. So a word problem. So it says members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The total cost for each member must be within $20 of 175. Which of the hotels shown can they consider? Okay. So again, this idea of being within $20, this should lead you to an absolute value inequality. So whatever's inside the absolute value, we don't really know right now, must be within or must be less than or equal to $20. Okay? So this is the idea here. Now, what's going to go inside here? Well, this inside here is going to be the total amount we spend, the total cost. Now, it's going to involve the $75, and it's going to involve the 4 nights, right? Okay. So here we go. So inside here, well, first of all, we're going to let X be the cost per night of a hotel room. So X is the cost per night. Costs. So now we're going to take the 4, because there are 4 nights being stayed. Sorry. Let me erase that. And we're going to subtract the already 175 that we know is part of the deal, right? That's what we have to spend total, or that's what we have to spend-ish, right? We have to be within $20 of that number. This absolute value must be less than or equal to 20. So what we spend for each member must be within $20 of 175, and that's what this means. So the reason that we set up this inequality is because now we know that this 4x minus 75 must be within negative 20 over here and positive 20 over here. That's what this absolute value does, right? So, we could be $175 less, or I'm sorry, $20 less than $175, or we could be $20 more than $175. And again, this is the and compound inequality. So we're going to put our less than here. So again, this can be greater than negative 20, or this can be less than 20. That would stay within $20 of your 175. And now we need to solve this for X. We need to find out what the cost per person could be. So again, 3 times. We're going to add 175. We're going to add 175. We're going to add 175. So I'm going to come over here with it where we have more room. So negative 20 plus 175 is 155. So again, that would be if you didn't spend any of the $20, right? You were $20 less than 175. That's 155. Less than or equal to 4x, which is left over so far. Less than or equal to, and now if we spent $20 above the 175, that would be 195. And now we divide all 3 parts by 4 to get X by itself. 155 divided by 4 is 3875. That's going to be less than or equal to X. That would be less than or equal to, and 195 divided by 4 is 4875. So this compound inequality are the costs per person per night, right? That our value can fall into. So we're looking at the hotels. Here are your 3 choices of hotel. Hotel A, $40. $40 fits within this compound inequality. That would work. Hotel B, $45 fits within this compound inequality. That would work. Hotel C, $50. That is not less than 48. Hotel C does not work. So which of the hotels can they consider? They can consider hotels A and B, but not C. And there you go. So again, absolute value and inequalities in general are great things to use when you don't specifically know exactly what you want to spend, but you have like a threshold, like this within $20. All right, great. So topic 1, solving equations and inequalities is done. Right? So we made it through the first topic. Great job. Thanks for watching, and we'll see you next time.